First of all, I'm extremely delighted to be the session chair of this virtual conference, Sustainable Development Goals 2030, which is organized by Vedant Knowledge Systems. And about my introduction, I am Dr. Subhankar Saha, Assistant Professor from Mechanical Engineering Department, Brainwave University. I completed my PhD and MTech in the year 2024 and 2016 respectively from National Institute of Technology, Silchar. And my research area particularly focuses on sustainable machining, sustainable material development, machine learning and optimization.
Namaste. I am Dr. Sajeeb Ayamannil, Professor at Government College of Engineering, Kannur. Here I am presenting a paper on investigating the potential of sawdust briquettes as a sustainable energy sources as a part of multidisciplinary international virtual conference on Sustainable Development Goals 2030, Viksit Bharat 2047. As an introduction, I can say that globally the energy demand is increasing day by day, and the conventional fossil fuels are depleting year by year, and many other resources are impacting the environment. As a solution for this, we can suggest biomass briquettes, which is renewable and eco-friendly and very much alternative to the fuel nowadays. And benefits of some kind of sawdust briquettes are they are very efficient and then they minimize emissions also. And the objectives of this paper is to assess the production, characterization and performance of sawdust briquettes. And sawdust which we are producing here is we have 5 different species: coconut, manga fruit, jackfruit, irul and mixed wood sawdust system. They evaluate all these sawdust and investigate their parameters, their density, bulk density, moisture content, ash content, calorific value and ultimate analysis. The methodology is we just collect the biomass from the sawmills and dried it, and then we use some piston press machine for making briquettes and dried under sun for 7 days, and do the testing for all these 5 briquettes made from different tree sawdust for bulk density, moisture content, ash content, calorific value and ultimate analysis for chemical composition. In the experimental setup, here is this. You can see that a press for making the briquettes, and some of the samples for the 5 different tree dusts are shown in figure. And we'll be using calorific value for finding calorific value. We are using bomb calorimeter, and then we use ultimate analysis for chemical composition. And as per the experimental results, you can see that bulk density bar chart and moisture content bar chart. Bulk density is more for coconut dust and mixed wood dust, and jackfruit dust showed low moisture content. Low moisture content will definitely leads to high calorific value in that matter. And then it is ash content and calorific value bar charts are shown there. Where ash content is very low for coconut sawdust, that is beneficial for that this kind of briquettes. And calorific value, this is the crucial part of crucial property for any fuel. In that case, jackfruit and irul will have more calorific value, and then we did some ultimate analysis for getting the chemical composition. All these sawdust shows say carbon content as from 25 to 50% carbon content, and then there is hydrogen content around 7%, which is also beneficial for the energy, good energy input. And another thing is carbon, the emissions, which definitely comes from the sulfur and nitrogen. So very low sulfur and nitrogen leads to very low emission also in terms of nitrous oxide and sulfur oxides. And all these contribute definitely to the environment. So because the sulfur content and nitrogen content are very low, which definitely leads to a very reduction in harmful emissions, and carbon neutrality will give us a very good greenhouse gas emission. And also this wood waste will be utilized, in fact. And I can conclude with that sawdust briquettes are very good sustainable alternative to this kind of fossil fuels as such. And the key results which we can get it from this paper is coconut briquettes normally is the best and most efficient, and jackfruit will have the highest caloric value. And then environmentally and economically these briquettes are very significant as well. And as a future worker, I can say that the parameters can be optimized, and also additional biomass can be explored, and life cycle testing can be done, and also we have advanced combustion technology can be done for this. These are the main references we have used in this paper, and open for question. Thank you.
So I reviewed the paper titled Investigating the Potential of Briquettes for Sustainable Energy Sources. So I expressed my heartfelt appreciation for the author who has written this manuscript, as this manuscript meet the objectives of the conference, as the paper is all about investigating the performance evaluation of briquettes which is obtained from tree species for renewable sources. So the paper is written in a very well structured manner, and it's technically sound, and the paper also comes up with some future directions, which is also very important. And the paper itself is very important for the practitioners who are practicing in this area. But apart from that, I have some observations which needs to be addressed. The thing is that the abstract should be more precise and brief, and it should present some quantitative figures. Apart from that, the literature review should include more recent literatures, and the methodology section should be backed up with some figures from experimentation, or how you have developed the briquettes. So this is all about my observation.
Good morning, everyone. I'm Dr. Shilpa R, Associate Professor working in Vidyavardhaka Engineering College, Mysuru. Regarding my introduction, I have done my bachelor's degree in NIE, Mysuru, and MTech in VLSI Design and Embedded System in SJC Mysuru, and I have done my PhD in PSC Mandya under the domain Signal Processing and Power Quality. And I have a total of 22 years of teaching experience, and I was also the IQAC coordinator and the NAC coordinator at the institute level for a period of 2020 to 2024. With this, I have more than 15 to 20 quality paper publications and more number of conferences, and I have 4 patents being published under my name. Thank you.
Good morning, all. My name is Bhavesh H Pithadiya from Department of Applied Science and Humanities from Madhuban and Bhanubai Institute of Technology, CVM University, New Vidyanagar, Gujarat. I have to present a paper, IoT-based energy-efficient innovative street light. India, the abstract is that the India's growing population face energy shortage and over a reliance on fossil fuels, threatening future generations. Addressing this requires energy-saving techniques, particularly in power limited systems. A proposed solution involves innovative street light design using a LDS sensor and ultrasonic sensor and low-cost module. The system automatically turns the street light on and off based on ambient light intensity using a LDS. The ESP32 enables the automatic and manual operations, the integrating with the Internet of Things for remote control. The ultrasonic sensor answers the lightweighting to 100% to 50% according to the requirement of movement requirement. Otherwise, power waste reducing during the inactive periods. So this is a smart, and this combination is IoT, so combining automations and smart sensors. So that is reducing the impact of the power shortage. This is an introduction. Due to the constantly growing population, India is one of the emerging nations that is a difficulty with the lack of energy resources, the power, and over reliance on fossil fuels can be lead to issue the impact of the existing future generation. To address today's energy shortage, it is critical understand to how to cut the energy use, implement the various energy saving techniques. So here we have to go smart or innovative street light. So this is a literature survey. That is this gives the that uh, it shows the highlights that transformative potential of IoT in the design and implementations of energy efficient innovative street light system. Here is the proposed system used to sensors a Wi-Fi module and IoT to create a innovative street lights to become a low cost and sustainable. The materials and methods, that is the ESP32, that is ultrasonic sensors that shows the 40 hertz frequency, and that requires a low current, that is a 50 milliamperes, and light dependent register, that is on automatic control the street light on. This is a block diagram of the system. Uh, that is ultrasonic sensor, LDI, and power supply to connect to the ESP32, and it's connected to the street light, and that is connected to the server, and the blink app is operated manually on and off the street light also. This is a flow chart of the system. The system effectively reduces the energy consumption by adjusting the street light brightness based on ambient light and proximity detection. That is light operated full brightness, and only when the motion was detected, otherwise the remains at the lower intensity 50%. The use of low cost component, the ESP32 electronic ultrasonic sensor and LDR provide a budget friendly approach to innovative street lighting solution. The conclusion of the system is the proposed intelligent street light system successfully addressed energy efficiency in urban areas by combining the automatic automations, IoT technologies, the system ability to dynamic control and intensity based on the motion detection and ambient light condition, minimize the unnecessary power consumption while ensuring the safety and visibility. Thank you.
This is the review for the paper IoT based energy efficient innovative street light. The proposed smart street lighting system presents an innovative and practical approach to addressing India's energy challenges. By integrating automation, IoT, and smart sensors, the system effectively minimizes electricity waste while ensuring optimal illumination for pedestrians and vehicles. The use of an LDR sensor for ambient light detection, an ultrasonic sensor for dynamic brightness adjustment, and the ESP32 module for remote control showcases a well thought out, cost effective solution. This design not only promotes energy conservation but also supports sustainable urban development by reducing reliance on fossil fuels. Sorry, your approach is commendable for its efficiency, scalability, and potential to make a meaningful impact on India's energy management efforts. An exhaustive literature survey has been done to study the existing methods, and the result that has been presented, that is, the system effectively reduces the energy consumption by adjusting the street light brightness based on the ambient light and proximity detection. And lights operated at full brightness only when motion was detected, otherwise, they remained at lower intensity. Uh, the use of low cost components like ESP32 ultrasonic sensors, LDR sensors. So it proves that it is budget friendly, and the approach is innovative in nature. Thank you.
Hello everyone, myself Professor Snehal Ghodake Nichale, Research Scholar, Zeal College of Engineering and Research and Assistant Professor, Cummins College of Engineering for Women, Pune, Savitribai Phule, Pune University, Pune, Maharashtra. I am presenting my work to a multidisciplinary international virtual conference 2025 under Viksit Bharat at the rate 2047. My research topic is data preparation for predicting air quality index by extracting features from sky images. The air quality index is a critical tool for understanding and managing air pollution. Its importance lies in several key aspects like health awareness, decision making for governments, policymakers, and environmental agencies. Public guidance such as avoiding outdoor activities during severe pollution as well as to understand global benchmarking. In short, AQI is essential for safeguarding public health, guiding environmental policy, and fostering informed decision making to improve air quality and overall well being. Air pollution can lead to various severe diseases, making an efficient air quality monitoring system crucial for safeguarding human health and managing air pollution. Currently, in India, 931 approved air quality monitoring stations are spread across 398 cities and towns. Currently, air quality monitoring relies heavily on specialized monitoring stations. However, their high setup cost and reliance on the expensive sensors make them inaccessible to many regions. With the widespread use of portable cameras and smartphones, images have become a powerful medium for conveying air pollution information. This paper focuses on image based air quality analysis, specifically, extraction of features which are important to categorize the images based on pollutant concentration. The proposed approach employs the image processing method for extraction of features and machine learning model for prediction of air quality index. For this research work, we used sky image dataset of India and Nepal, which is available on Kaggle, which comprises images captured at various locations and times, along with their corresponding pollutant concentration level. From the image, we extracted the feature like horizon line clarity, atmospheric opacity, cloud shape deformation, dynamic range reduction in image contrast, etc. The significance of above feature lies in its direct relationship to visibility and air quality. A well-defined sharp horizon indicates clear air, whereas poorly defined horizons suggest pollution. Measuring atmospheric opacity lies in its direct correlation with air quality. High pollution levels reduce transparency in the atmosphere, causing the image to appear more uniform and low in contrast. By quantifying cloud shape deformation through circularity, we can indirectly infer the presence of pollution. Dynamic range reduction in image contrast lies in its ability to indicate air quality condition. A reduction in contrast can signal the presence of pollutants that scatter and absorb the light. These extracted features apply as an input to the machine learning model. After training and testing of the model, we predict the air quality index. In this way, air quality index can be accurately estimated through image analysis. It would offer a cost-effective and efficient solution for monitoring air quality. Thank you.
Good morning, everyone. This is the review of the paper feature extraction and data preparation from images for air quality index prediction. The paper presents a compelling approach to air quality analysis using image processing and machine learning. Some of the positive aspects of the work. It gives increasing concerns about the air pollution in India and focus on air quality monitoring through image-based analysis, which is both significant and necessary. And there is an innovation that has been used in this approach by integrating the image processing techniques to extract the features of air quality assessment, which is an innovative approach offering a non-intrusive and a scalable alternative to traditional monitoring methods. And the usage of machine learning for pollutant concentration adds a modern data driven perspective, enhancing prediction accuracy and robustness. And about the dataset collection, the choice of the sky image dataset of India and Nepal ensures real world applicability, making the research highly relevant to the local environmental conditions. Overall, the paper presents a strong innovative methodology for air quality analysis, leveraging modern computational techniques. Uh, and the results are also, before coming to the results, the literature survey, a wide, extensive, exhaustive literature survey has been done, and a comparative analysis of the existing methodologies and what needs to be done has also been given. And the results part is more clear and with a logical interpretation, and the correlation between the horizon sharpness, atmospheric opacity, and pollution levels is very well articulated, making it easy to understand the impact of pollution on visibility. And the usage of again the use of image analysis as a non-invasive method to assess the air quality is highly innovative and practical, as I said before, especially in regions where sensor based monitoring is limited. The idea of quantifying cloud shape deformation using circularity as an indicator of pollution is a unique and promising approach, showcasing the depth of the feature extraction methods. Highlighting the role of contrast reduction in detecting pollutants is a very strong contribution. And the results not only provide a theoretical basis but also have real world applications in developing automated air quality monitoring systems, potentially benefiting urban planning and public health initiatives. Overall, my reviews like this. The findings contribute to a novel and insightful approach to the air quality assessment, and they strengthen the case for using image processing as a reliable alternative to conventional pollution monitoring techniques. Thank you.
My dear friends, greetings of the day. I am Professor Fazil Sheikh from the Department of Computer Science and Engineering, YCC Nagpur, Maharashtra, India. At the outset, let me thank Vedant Knowledge System for giving me an opportunity to be a session chair for India's biggest virtual conference on Sustainable Development Goals 2030, Bridging Gaps, Building Futures for Viksit Bharat 2047. Now it's been more than 23 years that I have been into teaching. My research interests include artificial intelligence, machine learning, quantum computing, etc. We all should collectively and proactively work together to achieve the sustainable development goals. My dear friends, most of the responsibilities lies with the education fraternity. So, yes, now I wish the conference organizers and all the presenters best of luck. Thank you.
Hello, good morning. Myself Kalpesh Patel. My topic is node localization in wireless sensor networks using swarm intelligence. Here is my abstract. Wireless sensor networks are pivotal in diverse applications such as environmental monitoring, healthcare, and military operations, where accurate node localization is essential for effective data gathering and communication. Traditional localization techniques like received signal strength indicator, that is RSSI, and time of arrival, that is TOA, are prone to inaccuracies due to environmental factors, leading to high localization errors and inefficiencies. Swarm intelligence methods, including particle swarm optimization.
Greetings, my dear friends. Here I am giving the review on the second paper, Node Localization in Wireless Sensor Networks Using Swarm Intelligence by Mr. Kalpesh Patel from Monarch University, Vahelal. Kalpesh, it's a good paper, well written and well organized. The algorithms like particle swarm optimization and colony optimization and the results you have described in detail. The introduction and methodology section, what I feel can be elaborated further, and few points I would like to mention, code is not expected in the paper, and I would like you to refer some latest papers, the papers which you have referred, are from 95 to 2019. Actually, you should go for some papers from 2022, 2023, 24, like that. And another thing is that the references are not numbered, so you have to enlist all the references by giving numbers like 1, 2, 3, and accordingly in the literature review or in the paper wherever you are referring, those numbers should be put in the brackets. Okay. Overall it's very good, so thank you for your efforts and best luck for the future.
My dear friends, greetings. At the outset, let me thank Vedanta Knowledge System for giving me an opportunity to be a session chair for India's biggest virtual conference on Sustainable Development Goals 2030, Bridging Gaps, Building Futures of Viksit Bharat 2047. Here I am giving my review on the paper Genetic Algorithm Based Biosensor Data Analysis Using Machine Learning Model by Mr. Shamimul Qamar, Hashim and Alaeddin from Saudi Arabia. Yes, dear authors, the topic is very good and there are a few points, yes, I would like to mention. First is that you should refer more number of papers. What I found is only 7 papers you have referred. So that count is to be increased, and latest papers you have to refer. Then there is literature review which is very short, and it is to be in sync with the topic which you have chosen. And yes, take these points as suggestions from my side. There is as such more clarity is needed in the proposed methodology and the obtained results. In the title you mentioned biosensors, but for experimentation you have taken MRI, CT scan and X-ray. So these are the imaging techniques. Okay, so in your future work I would suggest to go for some biosensor data which you mentioned in the title and experiment on that. So thank you for your efforts and best luck for the